my iLearn to you.
Oh, fantastic. Okay.
Okay.
Not seeing anything else yet, John. We just have a black screen.
How about now?
Yeah. Not yet.
I'm still black.
Yeah, mine too. It like showed up for a second. There it is.
There we go. Okay. So do we want to just work through them, or do we want to go over the ones you guys have trouble with, or what do we want to do? John, you're really garbly tonight. I didn't even understand anything you just said.
Well, we just start working on.
Courtney,
Yeah, I think we just go over, just start at the first.
Yeah,
Go
we
through
can
them.
start at the
And
beginning to make sure that we agree on what we've got going on. I guess I'm like about halfway done, it looks like.
I'm about 60% done, but I have to tell you, I don't feel very confident with what I did because I was just feeling, I don't know. I looked at it and I was blank. So I've been reviewing notes because I was just feeling blank this afternoon. So, but I've been doing Common Core with my kids, so it just throws off everything I do. So do we want to? What do we want to do, John? We lost your thing. Oh, are you?
Yeah, it's gonna come back up. I had to restart it. I thought it was not coming through, so I restarted it. Can you see that now?
It says, do you want to start? It's just lagging a little bit. All right, so on number 2 or 1, this is going to confuse me. I put A.
Okay.
Yeah, we are 90% confident the true mean heart rate is between
45 and 105.
Yep, that's what I put.
That's what I got too.
Okay.
And then plug in my computer.
Okay.
But you can keep going because I'm right here, so.
Okay. Well, if somebody else wants to read,
Okay.
We can just go through the questions or everything. Do we want to read the questions or just go through answers and stop when we have questions?
On this one right here.
Yeah.
Because of the actual question is just on 3. It says the researchers decided to construct a confidence interval to determine if the difference of means is significant. To determine whether the confidence interval would be reliable, they created a QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? And yes, because their samples were approximately normal based upon their QQ plots.
Mm-hmm.
So the distribution of means of each sample is normal since the data has been determined to be normal.
Okay, so I put B.
Yep, B.
Yep.
Right? B? Okay.
Cool.
B is yes.
Okay.
K4 says there are 4 types of confidence intervals listed below. Which one is appropriate for this experiment? And
wouldn't that be the bottom one?
I said, yeah, the bottom one, the interval for the difference of means using independent samples.
Right.
Yeah, I put the confidence interval for that bottom one, yes.
Okay. All right.
And
you want to just keep reading, John, because when we cut in, it cuts out everybody else. So if you want to just keep reading, we can just walk through this as we go.
Yep, sounds good.
Okay, great.
Number 5, a researcher is interested in estimating the saving account's balance of customers at a large bank. She obtains the saving account balance of a random sample of 30 customers. A 95% confidence interval for the mean saving account balance of bank customers is found to be between 3402.08, and 4142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95 confidence interval? And I chose the balance of 90 bank customers rather than 30.
Yep.
Because if you increase the sample size, you decrease the margin of error.
Right.
Perfect.
Okay, that's what I put too. I was debating that one with the compute the 99% of the 95, but then I reread my rule.
Because 99 would actually make it more inclusive, so it would make the margin of error larger.
Yeah.
Okay.
And then 10 bank customers rather than 30 would go down.
Yep.
So number 6, a factor makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their length, and finds their sample mean to be 1,000 millimeters. Their lengths are known to follow normal distribution whose standard deviation is 2 millimeters. Calculate the 95% confidence interval for the true mean lengths of shafts. So this is the one that let's see, where the mean x bar plus or minus 1.96 times the standard deviation divided by n, the square root of n. Sorry. So it's just a normal. So it's the one, whatever we're doing, the inference when the standard deviation is known.
Mm-hmm. And that's just the z. Is that just the yeah, okay. Confidence interval when sigma is known, right?
Yeah, it's when x bar plus or minus and whatever the z is, which can be 1.96. It can be like the 2.45. What is it? 1.68 is the other one that are common.
Yeah.
And so I come up with the interval being the first one, 998.04 and 1,001. Because basically you just take a 196 times 2 and divide by the square root of 2 is 1. So it's just adding and subtracting at 196.
Okay.
That work?
Yeah, no, that works. That's what I got.
Okay. To assess the accuracy of laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weights is computed. Suppose the scale readings are normally distributed with an unknown mean and a standard deviation of 0.01 grams. How large should n be so that the 95 confidence interval for mu has a margin of error of 0.001? And so I just used the formula, the n times z times the standard deviation over m to get 1960.
Okay.
Okay, so.
Is that, you guys got that one too?
Mm-hmm.
Yeah. I'm good on that one.
So yeah. So have you guys already? How many have you got up to 7 already figured out?
I've got up to, it looks like 15, but some of them aren't answered. Like 11, I didn't answer, and 13. So.
Okay, so for number 7, I got 1960.
Okay, that's what I got.
Okay, and the next one, let me see. The mean population mean of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis are, and I put the HO is equal to 1,250 and the HA, or the alternative, is less than 1,250. So the very first one.
Yep.
That's what I do.
Okay. Now this was, I had a question, number 9 I didn't get. And as In a statistical test of hypothesis, we say the data are statistically significant at the level of significance alpha if.
If it equals
Okay. So the way
5
you do this one is, if P is low, you reject the null. And so I think if P is larger than A, then it's statistically significant. Then we don't reject the null, which means we fail to reject it, which means it's statistically significant.
So you're saying the p-value is larger than alpha?
Yep.
That it's
Okay.
statistical significant?
Yeah.
Why won't it be that p-value is less?
Because if the p-value is less, then we say that we reject the null hypothesis, and so our data is not statistically significant. But that's what my line of thinking was.
Just statistical well, if it doesn't make it okay. So when I look at this statistical significant to me, because
Oh.
what they're measuring is if it's less than this. So if it's larger than that, then it doesn't change the null hypothesis.
So would it actually be that if the data significance, if the level of significance A is 0.05?
Yeah, that's
No,
what
because it can be, the level of significance can be 0.10, it can be 0.001.
Right.
It becomes significant because you can reject the you can reject the null hypothesis when that value is less. Was
So
my thought.
Well,
if
no,
P
if
Because
the
if
value
it's
is less,
larger,
then you're right.
because
If P is low, we reject the null. So then we say the data is not significant.
BP. No, just say it's low.
I think
Because
it's
well,
because the p-value is less than A, and isn't that when if we go under that, that's when we
reject it.
that's when we reject it. So that would make
That
sense
would
that the
make
p-value
sense that it
is less
becomes
than,
significant at that point.
right?
Yeah, I think it becomes statistically significant if it drops below the alpha. But you guys may,
I have a question on that. I have a question mark to go back to that one. So
yeah, on number 9, it's kind of I'll just leave it at being whatever you guys want to.
okay.
I think
Because
it's
to
the p-value
me,
is less
if
than
it
A.
doesn't
That's
become significant, it doesn't become an issue until we reject it, right?
Let me Google it.
I have to go. Do we want to go to the next one?
Well, Courtney's looking that one up, but we can go to the next one and talk about
Yeah,
it.
go ahead and go to the next one.
And this is another one that I didn't quite understand. It says a group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample size of 15 from each of the 4 different apartment buildings. The data of each apartment buildings are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis to answer this question?
I thought you couldn't use the ANOVA because with the ANOVA, it's got to be right skewed.
Correct.
Right? So it can't be that one. So it's got to be
Apartment buildings are bell-shaped.
that they don't have the true standard deviation of each sample.
Well, is it the true standard deviation? Because we're actually assessing the variance, not the standard deviation. So do we have enough data?
Well, I think it would also be, yeah, you wouldn't.
I think it's, well, no, you're right, John, you're right. It's no, we don't have enough data to make the thing, but we know it's not ANOVA because ANOVA would not do a bell shape.
Well, the datas themselves though can be normal. It's just that your ANOVA,
to the right.
It's just when you here, just a second, I gotta go in the other room.
You're okay.
But if you go into like just it's just too loud. It's okay. It's okay. It's just if you go to the ANOVA testing, they're going to be right skewed.
Okay.
Right.
Right.
So let's say the data for each building's bell shaped. That's our big key right there. Is it's actually supposed to be right skewed.
No, but the data sets can still be bell because the ANOVA is what's going to be right skewed, or no?
Well, so focus on the last question. If you read the last question, it says, can they use an ANOVA hypothesis test to answer this question? So when you do the ANOVA test, let me go through all my notes really fast.
Well, look at the data for each apartment buildings are bell shaped. I think that's the key.
Mm-hmm.
So this is what ANOVA says. ANOVA tests whether several populations have the same mean by comparing how far apart the sample means are with how much variation there is within the samples. So with that,
Yeah.
I'm
normally distributed. I think normally distributed and bell shaped is different.
I think you're right.
Because it says the two requirements is that the data are normally distributed in each group by checking the QQ plots.
Hi. Hey, Nanny.
And the variance are equal for each group. So I'm thinking because of that bell shaped with no outliers, I think that's the key that says we can't.
I think you're right.
But is it I think you got to choose.
Is it the C, we don't have enough data, or is it D, that we don't know the true standard deviation for each sample?
Well, we're not checking the standard deviation, we're actually checking the variance, aren't we?
Right, so we don't have enough data to compute that, right?
Correct.
So it's got to be C.
Have we started the quiz already? Is that what you're looking at?
We're looking through that.
Yeah.
Yeah, do you remember we were talking about starting at 6:30 today?
Oh my gosh, I totally forgot.
I should have called you. Yeah, we forgot until like 6:40, so we've only been going for like last 20 minutes. We're on number 10.
Okay, sorry. Oh my gosh, I totally spaced.
10, yeah.
That's okay. I did too.
Well, and I was studying and I forgot that we were going to start early. So I have to check out in like 15, well, I could push it to 20 minutes. So on that one, on number 10, are we saying no, they do not have enough data? Is that what we all agree on?
That's kind of where I'm leaning. Because we're not checking for the true standard deviation of each sample.
Right. Well, and I'm wondering if I'm still not totally convinced that the data sets themselves can't be normal. I think they can be bell-shaped or they can be bell-shaped and normally distributed because when you do the variance between those, those are what's going to make the ANOVA test come out to be right skewed.
Well, I thought I put yes because there was the sample variance are equal. Because I know that's like one of the factors if the sample variance.
Oh yeah, like.
Well, the sample variances are nearly equal, but is the bell shaped because it says the p-value, it is right skewed. So the data are normally distributed in each group. So the data are normally distributed. So does that mean a bell shape?
Well, it's going to be bell shaped, but I think the data can be bell shaped, but your ANOVA
then will be right when you put it into the ANOVA sequence.
Like I think your data can still be bell shaped, can be like normally distributed, but then the ANOVA results are going to be right skewed.
So bell-shaped means normally distributed, right?
Yeah. Yeah.
Right, yeah.
So it's the first one.
So that's the requirement, is they need to be normally distributed, and the sample variances are equal. That's true. So we probably can say yes.
And it would be the first
So
one.
yes, number one.
Yeah.
Okay.
That's what I put.
Yeah, because long as bell-shaped means normally distributed, I'm okay with that.
Mm-hmm. Yeah.
And there's no outliers,
So,
too.
have you guys seen on the lesson 15 review? It says it says there's a place for all the summaries.
Yeah.
Okay,
That's what I looked at.
that's really nice, and it just says like the ANOVA test, we use an F distribution, which is going to make our data's right skewed. The p-value is always the area to the right of the F statistic, and it says we can conduct an ANOVA test when the following two requirements are met. 1, the data is normally distributed, and 2, the largest variance is not more than 4 times the smallest variance. So I think that, yeah, we could do it then.
That's what I think.
Yeah.
And the sample variance has to be nearly equal to equal. So I'll go with that. How about you, Maddie, for number 9?
Number 9, oh gosh, my thing is being so slow. I put the p-value as less than alpha.
Okay. That's what we
Okay.
finally agreed to.
Yeah, that's...
Okay, number 11.
Do we want to read every question?
All the hoopla in that little thing there, it basically came down to that she rejected the null hypothesis, even though it was true.
That's
Yeah, I said a type 1 error.
Yep.
Yeah, so if you say it's false, but it actually is true, then it's type 1. If you say it's true, but it's actually false, it's type 2.
Yep.
So type 1 is what I called it.
Okay.
Number 12, if the level of significance alpha is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? And they're like a teeter-totter. As one goes down, the other goes up. So by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
That's what I put too.
So then in the next one, we are testing the hypothesis of the null being that the mean is 1.5 and the alternative being that the mean is 1 greater than 1.5. And so because of our sample mean, we got 1.53. And so we would reject our null hypothesis.
Right. Okay.
Okay. Am I still going to read them or
Yeah,
somebody else?
If you want to keep going, John, that's great. We'll just keep going, and we can, as we have questions, we can ask them.
Okay. 14, you would like to know look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? And because you're just randomly sampling 100 students and the males doesn't depend upon the females, I put an independent sample T.
Yeah, that's what I have.
Okay. An educator is interested in academic achievement by males and females with similar academic support. She decides to use brothers and sisters raised in the same home. Furthermore, decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent sampling or dependent? And I put dependent sampling because if you select a brother so as to compare his academic achievements to his sisters, you must include this sister in your study.
Yep.
Okay. Number 16, a social scientist collects random soil samples from a field and measures the dissolved organic carbon level of each sample. The researchers would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. And if you open the dissolved organic file and What test did you guys run?
On this one,
Uh-huh. So
this
confidence interval for the mean dissolved organic level. I put that the confidence interval, oh, it says, sorry, let's see.
I was
Of the
like,
4 types of confidence intervals listed below, which one is appropriate for this situation? And I said a confidence interval for the population when the standard deviation is unknown.
Unknown. Perfect. That's what I did.
okay, that's what I put.
Okay, which of the following is a 95% confidence intervals for these data? And I put 11.168 and 15.217.
Okay.
Has everybody got that too?
Um, so you just did like the one. Did you do? You just did the confidence interval. So did you just do like a one sample t-test?
Yeah, when you do that one sample t-test, you got to remember that when it's the one sample t, you have to use the you have to compute the difference. You have to make that little subcategory differences so that you can actually make a use the explorer to get that confidence interval, because you can't use the confidence interval of the one sample t because it's the difference of. Never mind. Let's see.
Because mine only has one line like of carbon levels. There's only one row of data.
Correct. And so then you've got to here screen share with me here.
Okay. So this is what I get when I open up the dissolved carbon.
Okay.
And then I just did the one sample t-test, and this is what I got.
Well, that looks like the same.
Is
Yeah,
that
so
the same?
the lower level is 11.16, yep,
Yeah.
and then the upper is 15 something.
Okay. I just thought you said something about having to like compute a difference, and I just didn't. I was like, ah. So.
No, you're good.
The distribution of it's the less than 6 one is the one that you got to worry about.
Okay, stop. You have to go away.
Okay.
Go away. You're not helping anymore. Shut my door, please. Okay, so now we're on 16, right?
Yeah, I'm gonna bring my thing back up again.
We're on 18.
Sorry. I'm
You're-
working off the worksheet because I couldn't get my computer to pull up stuff, so I'm working off my review paper.
Okay, it says a random sample of Hummers from sale in Los Angeles and New York were taken from listings at cars.com. We want to know if there is difference in means in listing prices between Hummers for sale in Los Angeles, Group 1, and Hummers for sale in New York, Group 2. So create a 95% confidence interval for true differences of means listing price between the two cities. And so if you do what they call it, of the 4 types of confidences, which one is appropriate for the situation? And it's the difference of means using independent samples.
Yeah.
Right.
Because, yeah. And then which of the following is 95% confident interval? And I put negative 42, 423 and 5,417.
Yeah, that's what I have.
Okay. So on the bone density, it says many studies have suggested there is a link between exercise and healthy bones. Exercise stresses the bones and causes them to get stronger. One study examined the effect of jumping on bone density of growing rats. There were 3 groups. Rats selected at random for the 3 groups. A control with no jumping, low jump, and a high jump. After 8 weeks per jump per week, whatever, blah, 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 the rats were selected. And then the question is which is the correct hypothesis test for this situation? And it's 3 different categories, so it's ANOVA.
Mm-hmm.
We have the control, the low, and the high.
So,
I got the test statistic, I got 7.978. The p-value, I got 0.002. And 23, I said that the significance, there's sufficient evidence to conclude that the bone density of at least one of these groups is different from the bone density of at least one of the other groups. Is that what you guys got to?
Yeah, that
So
makes
B.
sense.
Mm-hmm.
So B. And then if somebody wants to read that 24,
I can read that.
basically they wanted to compare a 90. They just wanted to compare 14 days to 90 days on the flight time. So that's a dependent because they're using this.
On the homework?
Yeah, this is homework for for lesson 13.
Yeah.
But you're changing the level of significance is the big thing.
So it's a dependent sample test. Right?
Mm-hmm.
The test statistic is 1.685. The p-value was 0.096.
Mm-hmm.
And because they changed the significant level to 0.1, it says there is sufficient evidence to conclude that there is a difference in cost of tickets purchased 14 days in advance compared to 90 days in advance.
Yep.
Is that what you said? So with that, how has anybody figured out a really good, like, for sure way other than, because sometimes when you read this, you think that it's like on our homework for this last lesson.
Mm-hmm.
For number, I read through it. I thought for sure it was like a independent sample test, and then it turned out to be a dependent.
With the couples?
Yeah.
Yeah, the reason they said that is because, like, the wife depends on who the husband is. And so I was thinking that I got it wrong the first time too, but that's what I came up with. But
Okay.
Okay.
So does somebody want to go through the? I can go through and repeat our answers.
or I can go through and then you can make sure that they're all the same.
Okay, so number 1 is true. Number 2 is A.
Yep.
3 is B.
Yep.
Oh, geez, here.
Courtney, why don't you read
Yeah,
it?
just read them off the screen.
I've got 4 is D, 5 is B, 6 is A, 7 is A, 8 is A, 9 is D, 10 is A, 11 is A, 12 is D, 13 is D, 14 is D, 15 is D, 16 is B, 17 is D, 18 is D, 19 is C, 20 is E, or A nova, 21 is C, 22 is B, 23 is B, 24 is C, 25 is A, 26 is B, and 27 is B.
Okay.
What did you say 7 was?
7 was A, 1960.
Okay.
Oh, and actually 9 is B. 9 is the p-value is less than A.
Yeah.
So is that what you come up with after you looked at it?
Yeah.
So it only becomes statistical significant is if you reject it, right?
Yes.
It would be.
Yeah.
And then for and number 10 we went with yes for A.
Yeah.
Okay.
All right. Does anybody have questions, or how are you guys feeling about the test? I guess
We get a piece of paper, right?
Yeah, we can use
Yeah,
the paper.
Did you guys see the email from her that Colby put together?
I didn't look at it, but I got it.
Okay, go in there because Colby actually wrote up all of the instructions for inference for one mean, inference for a mean with sigma unknown. He wrote up every bit of instruction for all of the chapters.
Oh, really?
Yeah, like he's got it all written out, all the equations, all the steps for SPSS, everything.
So just type that.
all
So
you
just
can
copy
do.
that onto a piece of paper and print it off, right?
You can actually, when you go into it, just press print and it'll send you a PDF file, and you can print it from there.
Just use that as a. That's what I think I'm just going to use as my 1 page of notes.
Yeah,
That's
I mean,
awesome.
it prints out to like.
So where'd you find that at?
It's in your email. She sent it out like
Earlier today.
I saw that. She said, please thank Colby or something like that for doing this.
Please thank Colby for doing that. Yeah. So it's everything you need. So make sure and print that out. Because from what she said, we can use that whole thing for the test. So that should help, but
I don't know if yeah, I thought I saw that. Oh, yeah, it's called hypothesis test. It was yesterday.
yeah, that one. So if you guys get it, email and I'll forward it on to everybody if you didn't get it. So.
And then when is because our test is open today then?
From what I understood.
Yeah, it closes Saturday.
Closes Saturday at midnight?
Yeah, 11:55, I think.
Okay.
Yeah, you have time. So, all right. Well, I have to go to stake training, so I'm gonna go and thank you for meeting earlier tonight. I appreciate it. So.
Sounds good.
Sorry, I totally blanked and forgot.
Well, we all kind of got on later than we anticipated, like 10, 15 minutes. So it's all good though.
Okay.
So
I got back from my lab at like 6:30. So.
Awesome. Okay. Well, good luck on the test, everybody, and I will talk to you on Tuesday. And I will hopefully email you guys this weekend with our project proposal. I started working on it. I'm just getting it together. So I'll email it out to you guys before Tuesday.
Hey, we got number 7 wrong.
For number 7?
Yeah. It's B, 38416, which is funny because that's the answer that I had. But,
oh, really?
Yeah.
I'm going to have to go back and redo that one.
So what did you guys do on that? How did you...
Get off my foot. Okay, I got to go, guys. I'll talk to you later.
Okay, bye. So I used the formula n equals z multiplied by standard deviation all divided by by the margin of error, and you square the whole thing.
Oh, that's true. Oh, you're right.
Z times standard deviation divided by
margin of errors, and you square the whole thing.
You square it. That's exact. Oh, I didn't see that.
Okay.
Oh, garbage. And so we got 9 and 10 are right.
Yeah. It's just 7 was the only one we got wrong.
That's not bad at all.
Good catch on that one.
Okay.
Okay.
Good luck, guys.
Good luck. See you next Tuesday.
Sounds good. Hey, Maddie, did you know that they have a biostats tutor from, I know, 7:30 to 9 in the library on Tuesdays and Wednesdays?
What do you mean? Like everyone goes and they just go through problems or something?
So in the math lab, do you know where the math lab is?
Uh-huh.
So they have like a tutor in there that knows biostats every Tuesday and Wednesday from 7:30 to 9. And then also from I know that's at least Tuesday and Wednesday. It might be every day. I just know that the tutor I go to, she's in there on Tuesdays and Wednesdays. And they also have someone in there every day from 11:30 to 3.
Okay.
So
I should probably go in.
Depending on how you're feeling. I don't know. They've just been really super helpful with stuff like that for me.
Yeah.
So. But
okay, I'll have to figure out when I can go.
Yeah.
Okay. Thanks for telling me. I did not know that.
Yeah. pretty cool. They're good. They're good tutors. So.
Okay.
All right.
I will see you guys Tuesday.
Sweet. Good luck on your test.
Okay,
Thanks,
good
you
luck.
too.
I know.
Bye.